guys, I'm Ernest. Welcome to our discussion in our channel of Sciences and Mathematics. Today we're going to look at the concept of a curl. We have already looked at the concept of gradient and divergence in some of our videos that we've already discussed on the concept of vector calculus. So for today, we are also going to look at one of the remaining aspects, that's a curl, and try to see how we can be able to represent it. So without further ado, thank you and welcome. So in this case, from the concept of the gradient, divergence, and curls, we said that the gradient is a vector while the divergence is a scalar product. And we're going to look at the last one, which is a curl. And maybe after we finish, if we find time, we will look at some of the equations which may consist of the important quantities that we talked about, which forms basically the concept of gradient, divergence, and curls, and maybe try to apply the combination of those either two out of the three concepts. So given the sample question on the board, which requests us to find the curl given the information of phi is equals x squared y z cubed and a is equals x z I minus y squared j plus 2x squared yk, then we're going to represent this curl of A as del cross A. So from this specific representation, we can be able to write a general, maybe an expanded form of that representation using del for the I component plus del for the y, which is j, plus del for z, which is k, and then cross A1, A2, A3. So these are some of those specific components. Now that's a general representation for that. Of course, we are going to do a substitution for these specific components that we have been given for I, J, and K. Therefore, I'm just going to do a substitution for that one because of space. So I'm just going to do away with this so that I minimize on the space that we've been given. So this is going to be del x I plus del y j plus del z k, the cross of A. So for this A, we are going to have z I minus y squared j plus 2x squared y. Okay, so this is how we're going to try and represent this specific curl that we have been requested to find. And basically for the cross of this, we're going to use the general representation as we do for matrices, which is going to be given as del for x, for y, and this is for z. Basically using those components of A that we have been given. So this is negative y squared 2x squared y. So finding the cross of that one, this is going to give us y into x squared y minus dz. This is a negative y squared, so this is going to be for I plus. Now basically when we do this one, it's a plus minus k, plus minus plus, trying to find a matrix. I hope that we understand that concept. So there's going to be a rearrangement of the second part of that specific cross multiplication. Therefore we're going to have this one z x z, and then e x 2x squared y, and this is going to be j, and then lastly plus dx minus y squared So this basically, if we do a multiplication, is going to give us 2x squared for I plus x minus 4 xy for j, and then the k component is not present from that evaluation. So therefore, we're going to have a representation for the curl of this specific vector A, represented as shown above. Now we're going to talk about the concept of those two identities that we mentioned during our discussion for gradient, divergence, and curls, or the two important identities that we have talked about for the div curl A, which is equivalent to 0, and the curl grad phi, which was equivalent to 0, and in our next video. So for today, I think this, in conjunction with the gradients and divergence that we've already discussed, it's going to assist us in trying to perform some of the operations that we may come across in vector calculus and other topics. Now these are compounded together for the gradient, divergence, and curls. As we said, they're going to form a basis in some of our applications for electrostatics, fluid dynamics, and maybe in other areas that may require application of concepts of fields. So in this case, I'm going to wind up that one for today, so that I reserve maybe the last two that I've already talked about in other videos. So that is it. Bye guys. God bless.